In this video, we will learn how to interpret the value of the Lagrangian multiplier. Let us say we have a simple utility function, that is, we have utility is a function of two goods x and y which are related with, that is, x times y. This is the utility function. Let us take a simple budget constraint, that is x plus y is equal to, let us say, 12. So the consumer's endeavor is to maximize the utility subject to the given budget constraint, where price of good x is 1 and price of good y is also 1, and this 12 denotes the income of the consumer. So I will not use the graphical method. Let us solve the given question using the Lagrangian multiplier method and explaining the value of the lambda that we will be deriving here. Okay, so as we know from the constraint optimization, to solve this question, we set this constraint equal to 0. That means we get 12 minus x minus y is equal to 0 first. So then we multiply both sides by lambda, and then we form the Lagrangian function, that is L is equal to the objective function, which is x times y, the utility function, plus we add the resulting constraint, that is lambda times 12 minus x minus y. Okay, so in this video I will be explaining the value of the lambda that we get from the optimization problem using Lagrangian method. Okay, so we know that for optimality we require the conditions that we partially differentiate the Lagrangian function with respect to x, y and lambda and set them equal to 0 simultaneously. That means, so L subscript x means the partial derivative of this function with respect to x. So derivative of x is 1, so we are left with y. Here derivative of x is 1, so we are left with minus 1 times lambda. So we get minus lambda and we set it equal to 0. Similarly, L subscript y means we partially differentiate this utility function this time with respect to y. So derivative of y will be 1, so we are left with x. Similarly, derivative of constant is 0, derivative of x will be also 0 because we are taking partials with respect to y. Derivative of y is 1, so we are left with minus lambda. So derivative of y is 1, so we are left with minus 1 times lambda, which is minus lambda, and we set it equal to 0. Similarly, we take the derivative with respect to lambda. So derivative of the first function, first term is 0, derivative of lambda is 1, so we are left with 12 minus x minus y, and we set it equal to 0. When we solve this first equation, so what will we get? This equation, which implies y is equal to lambda. Here also it means x is equal to lambda. Let us say this is equation first, this is equation second. So dividing equation first by second, we get y upon x is equal to lambda upon lambda. Okay, solving further, we will get y is equal to lambda gets cancelled, we are left with 1, so y is equal to x. Now we plug the value of y is equal to x either in this equation, or we put the value here in the given budget constraint. Let us put the value in the given budget constraint. So we have x plus, in place of y again we have x is equal to 12, so which becomes 2x is equal to 12, or x is equal to 6. If x is equal to 6, that means y is equal to 6. These are our optimal, these are our optimal values. Now what is the value of lambda? Simply plug x is equal to 6 or y is equal to 6 in equation first or second. Let us plug x is equal to 6 in the first equation. That gives us y is equal to 6. Okay, let us plug the value of this. Okay, so y is equal to 6, so 6 is equal to lambda. That means the value of lambda came out to be 6. Now what does it imply? The value of lambda, okay, let me write it here. So this Lagrangian multiplier measures the impact on the objective function caused by 1 unit change in the constant of the constraint. Let me repeat it again. So the value of lambda or Lagrange's multiplier measures the impact on the objective function, that is the utility function, caused by 1 unit change in the constant of the constraint. What is the constant of the constraint? It is here income. So this lambda measures the marginal utility of money, or let me explain it here. So for that, let us take the value of, or let me explain. It simply tells us how much our utility will increase when the constant of the constraint changes. So what is the constant of the constraint? It is the income here. Okay, so it simply tells us how much utility will increase when our income changes by 1 unit. So the lambda explains us the change in the utility caused by the change in the income. Okay, so if I try to solve this, I don't have the apparatus here this time, so let me write it here. So let us say the constant of the constraint increases by constant of the, so we have x plus y is equal to 13 this time. So we change the constant of constraint by 1, that means income we increase it by 1 unit. Then what will we do? We again solve the given utility function, that is u is equal to xy, such that x plus y is equal to 13 this time. When we solve this time using Lagrange's method, we will get x, the value of x the value of x that we will get will be equal to 6.5, and the value of y we will get as 6.5, and the value of lambda we will get 6.5. Okay, now let us compare. Let us first calculate the utility that we derived here. So here the utility that we derived will be equal to, so u will be equal to, so we got the optimal values here 6 and 6, so x times y is equal to 6 into 6, which is equal to 36. Initially we got the utility level of 36. Okay, now what is the new utility when the constant of the constraint changes by 1 unit? That means when income increases by 1 unit. So we find out the new utility level. Simply plug what we call 6.5 and 6.5 in the objective function. So we have 6.5 in place of x times 6.5. So it will come out to be 42.25. Okay, so the change in the utility will be equal to the new utility 42.25 minus the initial utility that we got, that is equal to 36. So we have 36. When we subtract, we will get the change in the utility will come out to be 6.25 something, so which is approximately equal to 6. Okay, that we got the value of lambda. Okay, so the point I want to make here is that this lambda is equal to 6. It simply tells us if income increases by 1 unit from 12 to 13, utility will increase by 6 units, that we have found out here. That means initially our utility function was x times y, and initial optimal points were 6 and 6. So initially we got the initial utility of 36. Now when we changed the constant of constraint by 1, so we got the new utility equal to 42.5. So it simply tells us that here lambda is equal to 6 means if utility if the income increases by 1 unit, utility will increase by 6 units. That is the main essence of the Lagrange's multiplier, and it simply tells us the shadow price or marginal utility of money. I hope I make myself clear in this video. Thank you.